Good morning, my dear students. So, you know that everything has a beginning and everything comes to an end, whether it's a good thing or a bad thing. A long time ago, we started our lectures from the topic cell, nucleic acids. Now we are coming to the final lecture, where we'll talk about how we live on this planet, how we should live on this planet. We studied lots of things, how students, how you've been taught to maintain discipline, to attend classes at 8 o'clock, to manage winter weather, snow. And during this period you learned about our bodies, our growth, our development, about surrounding organisms which are not always friendly. Previous lecture we talked about how we change, and today we talk how we should live on our planet. Today is very interesting and key lecture for understanding what is biology. Okay, so today we talk about biosphere and ecological aspects. The term biosphere is quite old term. It comes actually from the 19th century, and the first person who introduced the term biosphere, living sphere, as you know, was Edward Seuss. The doctrine of biosphere, however, was developed by very famous scientists. The scientist whose name is written on the front building of our university, which is written in all your record books, is V.I. Vernadsky. Who is V.I.? Please remember that V.I. stands for Vladimir Ivanovich. So the doctrine of biosphere was developed by these brilliant scientists, which gave the name to our university. Why our university has the name of Vladimir Ivanovich Vernadsky, I will tell you a little bit later. So Seuss just named all living organisms, and Vladimir Ivanovich Vernadsky said that living organisms do not just only inhabit our planet, that they actively change our planet, run our planet, and our planet look like this today mainly because of the power of the living organisms. If you read the words of Vernadsky, what he said that the biosphere is the field of active life, an integral self-regulating open system, a general planet envelope, and it became isolated by the development of the life on the Earth. So the biosphere, like all spheres of our planet, it has its borders. How it's been run? The biosphere is being run by the events which are called, by the relationships which are called trophic chains, which I'll also mention today. So energy flow in the biosphere, active part of our planet, is maintained by their trophic chains. So what are the borders of biosphere? How deeply, how far, how high life can go? Does it exist everywhere? Our planet is quite big, but life cannot exist everywhere. So biosphere has its borders. And I remind you that many of you still have to pass exam tests. And some tests which we will give you, they will be brand new, which are not listed in your copybooks and in the database which we give you. So some questions are included in my lecture, and if you listen carefully to my lecture, you will find these answers during exam. So the borders of biosphere, where life can go, where life can exist on our planet. Be careful. So you know that our Earth has three main spheres, three main envelopes. Above of me is atmosphere. It has troposphere, it has stratosphere, it has ionosphere. So where life can exist. Though atmosphere can go more than 30 kilometers. Actually, the life exists only in a small area of atmosphere. The possible active forms of life, plants, animals, are found up to the 6 kilometers. Yes, you can find them upper also, it is possible, but this is accidental life forms which die very quickly. There were possible findings that spores of bacteria and fungi and some plants also were found at the height of stratosphere, 22 kilometers, was possible findings, but these forms were not active anymore. So life in the atmosphere, active forms of life, can numerously exist at the height till 6 kilometers. If you go more than 6 kilometers, if you go 8 kilometers up to Mount Everest, for example, there will be a limiting factor which will stop forms of life, which is absence of oxygen and extreme temperature, plus increase of sun radiation. More up you go, more sun radiation becomes stronger. That is important for pilots who fly very high all the time. So upper border of atmosphere is 6 kilometers. Other forms can be found higher, but these forms of life go there accidentally and live there for the short period of time. Maximum possible height for the forms of life found was 22 kilometers. Then, water envelope, water sphere, which we call hydrosphere. Hydrosphere actually is inhabited fully. The deepest part, which we know in the world ocean, it is called Mariana Trench. The depth of Mariana Trench is 11.5 kilometers, and this Mariana Trench is also inhabited. Limiting factor in the hydrosphere which stops spreading life very deep are huge water pressure and very low temperatures. But in the bottom of Mariana Trench, we found bacterial forms of life. You know that bacterial forms of life are very ancient and very resistant. So hydrosphere, border of hydrosphere for the biosphere stands for 11.5 kilometers. But if you want to find abundant life in the hydrosphere, most abundancy goes up to 200 meters in the hydrosphere. Because after 200 meters, the amount of sunlight which goes in the hydrosphere become limited, and many algae, yes, many phytoplankton cannot simply grow there. So hydrosphere border is up to 11.5 kilometers, but most abundancy is met up to 200 meters. And the final stone hard envelope where we stand on right now, yes, is called lithosphere, yes. And the border of the biosphere in the lithosphere goes up to 10 meters. Some scientists said for 20 meters, but mostly life goes up to 10 meters, where the roots of most trees can go down. So where soil exists in the lithosphere, life also goes there. Yes, so life goes mainly within the soil. Yes, some bacteria can live nowadays, we find them deeper, but most of living organisms can go only down up to 10 meters. What is the limiting factor which stops them for spreading in the soil? Again, absence of light, absence of oxygen, and increase of temperature. More deeply you go down to the earth core, more hotter it becomes inside. So people who work in miners, they suffer from extreme heat. Yes. So the borders of biosphere are not very big. So biosphere is this overlapping part of spheres actually, so you could understand. So in atmosphere, border goes 6 kilometers. In lithosphere, border goes to 10 meters. And the hydrosphere, we go up to 11.5 kilometers in the Mariana Trench. And this small part, overlapping part where life is possible, is called biosphere. but though it is small, it is very active and important part of our planet. And in this part, of course, humans live. Okay, so according to Vladimir Ivanovich Vernadsky, biosphere is composed of the following parts. So most important and driving part of the biosphere, which changes non-living things, is called living substance. Though it is small, relatively small, according to the mass of all biospheric substances, yes, it is a very active and important part. Then we have biogenic substance. What is biogenic? Biogenic, generated by life. Substance which was once alive, but then it became dead. So substances of organic origin. You know them very well, we call them fossils. And this is oil, this is gas, yes, atmospheric gases too, by the way, yes, we'll mention it. Biogenic sometimes mixes with stone or rocky substances, yes, debris of living organisms, and create soil because of this. And of course we have non-living parts on our planet which were never been alive. We call them stone, rocky substances. For example, these are mountains of magmatic origin, basalt, granite, etc., which were never been alive. We have radioactive substance in the biosphere, yes, and we have dispersed atoms and molecules. So composition of biosphere is living things, living material, then non-living. Non-living can be classified into biogenic, into stone or rocky substances, into dispersed molecules, and radioactive substances. It's not very hard at all. So some things never been alive, some things are non-live but once were living. It is very simple. It's actual school program. Okay, this abiotic and biotic part in the biosphere are intimately intertwined. So all living and non-living things in the biosphere are very closely interacting. It is very, very important. So, as I told you, the driving force of biosphere is living material, are living things. So what do we call living things? What did Vernadsky call it? Very powerful geological force. I remind you that living things have seven main characteristics. Yes. So if you want to find living or non-living, if you match the organism or possible organism by these characteristics, then it's living. Yes. Living substance has two main properties in the biosphere. First is biomass. First criteria how we measure living material in biosphere is biomass, how much it weighs, and second it is bioproductivity. So how many carbon is fixed, or how many organic matters are produced. So productivity means in how much time does the mass of organism increase per unit of square. So some organisms multiply quickly and their bioproductivity is very high. Some organisms multiply very slowly and their bioproductivity is low. If you want to know how productive in general aspect of living organisms are, here are the facts that during the photosynthesis cycle, yes, per 1 year, our planet make approximately 46 billion tons of carbon and release more than 123 in 10.9 degree tons of oxygen. So our living organisms are very, very productive. Living substances are very diverse. Yes, as you know from evolution, why it happens, why diversity comes. So they consist of 500,000 of prokaryotic plant species. Yes, and more than 2 million species of animals. Yes, so life on our planet is abundant, but in ecology, during ecology, but I will tell you that this abundance is under big threat because of human activity. So this living matter, why its geological force, how it changes the planet, this living matter has 7 functions. So Vernadsky said that the main geological force which changes appearance of our planet, which gives us modern look like it is now, are living organisms. So they have mass, they have bioproductivity. And how do they change our planet? They change our planet by 7 basic functions. So first function of living things is energetic function and participation in gas formation. So how you can change something? Yes, you need to have energy. If you want to come to university, you need to have energy. If you want to study, you need to have energy. Yes, if you want to do something, move your hand at least, you need to have energy. Where it comes from? Energy of the living organisms mainly comes from the sun. Yes, so sun gives huge amount of solar energy. 1% of this energy is taken by green plants, algae, yes, everybody who can do photosynthesis, and converted into glucose and oxygen. This glucose from plants is passed to animals and goes further by so-called trophic chains. And this energy from food we use to transform our planet. The side effect of photosynthesis is making oxygen. Yes. So when you make oxygen, you create atmosphere. Yes, you change the atmosphere, you contribute into new atmospheric events. So this function is very easy to understand. Next, interesting aspect of this function is that many energy is not used in food chains, which is stored by plants, and it become eventually converted into biogenic substances, which is called fossils. And these fossils we use further to run our industries, to heat our houses in winter, for example. Yes, and this additional energy from fossils human can use as a benefit to transform our planet more intensively than other creatures. If, for example, bird has only energy which it gets from food, from grain, from worms, human has all sources of energy which is possible to get from our planet. And first of all, initially it was energy of fossils, which human actively used to build modern industry. Then, second function, or third function, if we unite energetic and gas function, is concentration function. A very interesting function, you can observe it almost everywhere, is that living organisms are able to accumulate in their bodies certain chemical elements or compounds. So it can happen if the organism consume these elements by food, or some of them can absorb the elements from different solutions, from water. And more bigger the organism, more intensively it consumes another organism, smaller organisms, more amount of substances can accumulate in its body. So when we'll talk about food chains, the predators which stands on the top of food chains, yes, predator species which we consume into food, nowadays can accumulate huge amount of toxins. So this concentration function can be good if we change our lithosphere, and it can be bad for human health, because all toxins which we release in the atmosphere, lithosphere, hydrosphere, eventually can accumulate in the body of fishes, animals, which we use in plants, of course, which we use further in our food and eventually go in our body. Most elements, especially heavy metals, they are never eliminated from our bodies. It's very, very hard, almost impossible to eliminate. And more longer you consume toxic substances, more higher concentration of the substances will accumulate in your body. So this is concentration function. This concentration function you can observe in the deposition of different natural minerals. Most common and classical example is chalkstone, limestone. Yes, these are natural minerals. They all appear because living fossils, which were once living, actually stored calcium carbonate in their bodies. Layer by layer by layer by layer of these fossils got accumulated, yes, within centuries, millions of years actually, and eventually compressed into rocks and mountains. If you want to see the example of concentration function, you can travel to the area of Belogorsk when quarantine will be over, because it will be over one day, and you will see very beautiful geological object which is called white rock. If you look at the white rock, you can observe that it is fully made of limestone. And once, long time ago, Crimea was actually the bottom of ancient sea. Yes, Crimea was once underwater, and it was slowly rising up. That's why many mountains in Crimea are made of sedimentation rock, because a long time ago Crimea was the bottom of ancient sea and many fossils were living inside. So if you want to see prehistorical seaside, yes, prehistorical bank of sea, you can go to this area and look carefully at the white rock, where you'll find imprints of shells, maybe ancient fishes too. It is all vividly visible there. Just be careful, okay? So, if we make things, we also break things. So next function is destructive function. So organisms which we are called decomposers, they are able to break organic substances into inorganic, for example carbon, phosphorus, nitrogen, and involve them again in the biochemical circulation. Destruction function is also done by plants. You can see plants, lichens, algae sometimes grow on the rocks, break them into small parts. These parts are mixed with the parts of plants and animals and form soil. Yes, and actually Vernadsky found his doctrinal biosphere because he studied soils, and he noticed more soil is fertile, more organic compounds it has. So more living organisms were living in this place. So trees break the rocks, dust of rocks mix with debris of living things, and soil is formed. More organic part soil has, more fertile it is for growing. So destruction. So circulation of elements, soil production. Decomposers, you all know these animals, yes, so they are very essential part of our ecosystems. What is ecosystems? I'll also tell you today. Okay, transport function. We can also transport different elements, compounds, chemical compounds, and organisms can actually carry them on a quite large distance, in their bodies. Yes, from one side they can help in mixing substances. From another side, they can create deposits of the substances in different places. And more intensive migration happens, more biochemical cycles are possible to run. More biospheric system is stable. Homeostasis in the biospheric system is more stable. So, and the last but not the least is environmental function. The different organisms which live together, like trees which form forest, sedimentary rocks, they change climate. Yes, they affect climate very greatly. For example, when it's very hot in the city, impossible to stay, you can go in the forest and you will feel that forest has much more comfortable temperature, because trees evaporating different fluids, liquids, and decrease the temperature. Sedimentary rocks, they change the direction of wind. Yes, they can call clouds also. So environmental function. Different organisms can form environment, and believe me, living organisms make environment very comfortable, much more better than humans. So living matter in the biosphere is arranged into very accurate and delicate hierarchy. It tends to maintain stability. And if human intervenes in the cycles, in the 7 functions of living organisms without knowing it, it leads to disasters. It leads to different disasters. So how did the organisms change our planet? What did Vernadsky said? How did he explain this? So long time ago, our Earth didn't have oxygen in the atmosphere. It had CO2, it had methane, possibly, yes, but it didn't have oxygen. Oxygen appeared because somehow, we don't know still how it, we cannot answer this question. Somehow, more than 5 million years ago, on our planet appeared first life forms. Yes, bacteria, and some of these bacteria managed to run photosynthesis. As the side product of photosynthesis appeared oxygen. And this oxygen accumulated more and more. Eventually, upper layers of this oxygen, they underwent exposure to the sun radiation and turned into ozone layer, ozone screen. O3, if you don't remember what is ozone. Because of ozone screen, the amount of sun radiation which was affecting our planet greatly diminished, and not only unicellular forms but multicellular forms of life start to appear. Yes, because before that only unicellular forms which lived few seconds would exist, because sun radiation would broke any more complicated molecules. Yes, more complicated cells. So after we received ozone screen, multicellular forms of life became possible, and the further geological processes start to run. Yes, so changes in the atmosphere, changes in the climate, formation of sedimentary rocks, formation of soil, and this is example how our living organisms changed our planet, and still they are changing. But main driving force, main geological force who changes our planet belongs to humankind. So we are mostly responsible for what is happening to our planet and why it's looking today like this. Because living organisms, they have only food energy, and they change our planet slowly. And we have fossil energy, nuclear energy, solar energy, wind energy, etc. And we can change our planet much more rapidly. So if we intervene in the biochemical circulations, if we break them, we break ecological systems, and we break different biospheric processes. And their consequences can be very dramatic. So Vladimir Ivanovich Vernadsky, he found out the defined 7 functions of living matter, said that it is the leading driving force. He pointed out that the main driving force of today is humanity, and he said that the biosphere and our planet also undergoes the process of evolution. So he thought, and he tried to tell people that our planet stands like separate living organisms. Yes, he said that biosphere, for example, can be defined as global ecosystems, as a sum of all ecosystems, yes, which exist on our planet. And he said that our planet can be treated actually like a giant living organism. And like all organisms, it undergoes its evolution. So first of all, according to Vernadsky, when our planet appeared, it didn't have life, it was called geosphere stage. Geosphere stage. After life appeared, and presence, till present time, it was called biosphere. And now we came to the third stage, of biosphere evolution under the influence of human, which is called noosphere. Noosphere. Please remember the word noos. The word noos from a Greek comes for the mind. It's translated like the mind. For example, if you don't like biology, if you're waiting for third course, okay, you will study there nootropic drugs which increase mental activity, for example. So noos, please remember this word. So noosphere, this is your class question, this is your exam question, is the intellectual envelope of our planet. It is sphere of human mind. And according to Vladimir Ivanovich Vernadsky, this is the sphere of human cognition and human activity. This is the third stage of biospheric evolution. So Vladimir Ivanovich Vernadsky, I think you should know a little bit about this person, because when we come to exam, most of students even don't know his name. If you want to study 6 years in the university and you don't know the name of the founder, I think it's a bit of shame, yeah? So Vladimir Ivanovich Vernadsky was a prominent Soviet scientist. He was born a long time ago in 1863 in Petersburg, yes? And after that he moved to Ukraine, where he was founder of new science, which was called soil chemistry, yes? And he studied different soils. And under the influence of his studies, he said that compositions of soils can be different because of different contribution of the living organisms. And his most merit, that he said that life can change on our planet, and our planet also undergoes evolution itself under the activity of the life forms. So main part of biospheric doctrine was part which was devoted to the noosphere. So under the control of human, our planet should turn into very, very harmonically organized interaction of technosphere, human activity, and natural ecosystems. So the main thought of Vernadsky was that humans should understand what is our planet, what processes go inside of our planet, how it changes, and build their industrial activity, build their cities according to the rules of nature. Because if you break something, very small piece in natural ecosystems, it can have disastrous consequences. So he was founder of geochemistry, biogeochemistry, radiology, radiogeology also. So he studied, again I told you, composition of soils, and he devoted many time to the science, to the education. He spent some time in Crimea, and he said that south of Soviet Union, it was that time, of course, required some institutes to make people more educated. And he was the first rector of Tavrida University. Yes, still it exists, of course, it's a part of KFU now. And he was initiator to make here university, which bears his name till today. So when Vernadsky wrote his doctrine about biosphere and its transformation into noosphere, many people didn't take it serious, as always, and only in the 20th century, in the end of 20th century, many people, and of course 21st century especially, many people start to go back to his studies, and this concept of noosphere start to have second life, because people tried to run our planet like they wanted without natural laws. People thought they could master our planet, yes, use it wherever and however they want, found that it is not like this, found that there will be dramatic consequences, very bad consequences, and after they made mistakes, yes, like bad students, they try to rework these mistakes. They try to understand now how they should run the planet. Not all people, but most of them started to think like this. So I told you about Vladimir Ivanovich Vernadsky. All of you know this building. All of you know this building. Of course, he contributed to Ukraine Academy of Sciences. Yes, he had many students, whom of them became professors, academicians, and he wrote more than 700 scientific papers, which are started to being reviewed nowadays, and people only now try to understand what Vernadsky tried to tell them in 1929 when he wrote his book about biosphere. Okay, so Vernadsky hoped very much that people would listen to him, that people will understand that our planet is very delicate, very complicated, and we should run our activities and change our planet according to natural rules. But people did mistake. Most of people went wrong way, and our planet didn't turn into complete noosphere. So we didn't run our planet wisely. Most part of our planet is converted into technosphere. What is technosphere? This is the part of planet which mainly consists of artificial nature, for example, like cities, yes, and where all natural laws are almost broken or completely broken. What happens if we break natural laws? If we don't run Earth according to the biospheric concept, if we don't follow natural rules? We receive environmental pollution. We come to the environmental pollution. So people take from our planet, and after they take, they emit huge amount of waste products which accumulate in the nature and cause environmental pollution. How biosphere affects our health? The answer is very simple. Already in the end of 19th century, many scientists pointed attention that humans have very unfavorable consequences by its activity upon biosphere. Nowadays, humans emit in the nature up to 2,000 new chemical pollutants every year. So every year approximately 2,000 completely new chemical agents go into environment. They pollute all three parts of our planet. They pollute atmosphere, they pollute hydrosphere, they pollute lithosphere. So more than 60,000 of found defined chemicals are found nowadays and affecting human health in the food, water and air. According to the World Health Organization, more than 80% of human diseases develop due to polluted environment or because of human activity, wrong way of life. So the number of diseases which are provoked by polluted environment, yes, polluted biosphere around human, is growing dramatically from year to year. When we talked about ontogeny and we talked about long living conception, I told you that things which cause aging can be graded into few positions. First position, which defines the length of your life, is your genes. So if you have special program, genes of longevity, telomeric restoration, you can live quite a long life. Second factor which affects your life is your way of life, what you do with your body. And third factor which affects how long will you live is environmental factor. So which water you drink, which air you breathe, which food you eat. You can have very good genes, but if you work in the heavy industry factory, of course you will die much more earlier than 60 years. If you drink water like this, or if you eat fruits which were watered by water like this, no matter which genes you have, you will not last long. I think it should be obvious for you, no matter how rich you are. So most of people on our planet drink water which is harmful for health. So water is intensively polluted by industries. Yes, the factories take clean water and emit outside dirty water. Different chemicals from atmosphere accumulate in the water. Yes, garbages which we make, they go to the water with the rain, yeah, or they go into the water directly, and all these chemicals start to dissolve and go to our taps and glasses of water, of course. And lots of these waste products, heavy metals, chemicals, which I told you before, they accumulate with fish, inside of fish, which also goes in our food ratio. If you want to know, because of accumulation function, yes, the number of toxic things inside the fish, for example, river fish, yes, can be enormous. And for example, United States of America, they prohibited import of fish from China, because fish from China mostly grows in the very polluted rivers, and people of America didn't want to buy such fish. Now you know why. So if you want to buy fish, yes, it should be grown in appropriate conditions. It's a very, very important, because fish accumulates lots of toxins, and from its meat they travel to your body. If you want to know what happens with your body when you consume, for example, heavy metals, for example, I will give you a small example of accumulation of strontium in your bones. Strontium is quite common radioactive metal, which can be present in food, which can be present in industrial dust, and which can easily accumulate in your bones. If you expose to small amount of strontium, yes, it will accumulate in your bones, but nothing terrible will happen to you. It will be small amount. But more and more, this element, year by year, accumulates in your body, it increases its concentration. When the concentration reaches some point, some level, some toxic level, it starts to show its toxic effect. So when concentration is small, maybe you'll not feel it, but it grows year by year by year. It is possible if you live in the dirty area or you eat export food. And once you wake up and in your bones you have small radioactive focus of your personal strontium accumulation. What will a radioactive focus in your bones will do? Cause the cancer of bone marrow, for example. Do you understand? So eating of toxic things, if you once or twice, okay. But if you will eat it year by year, eventually it will ruin your body. And once heavy metals, chemical compounds accumulate in your body, it is very, very hard to eliminate them from there, or almost impossible. If you don't like example of strontium, okay, please note that nowadays we use plenty of plastics. We use plenty of plastics in all countries. It doesn't matter which country it is. Plastics dissolve, of course it dissolves. That's why I told you never to use hot plastics, never drink hot drinks from plastic cups. And micro amounts of plastics accumulate in your body. What microplastics does in your body? It initiates different processes of cancer, and of course it affects blood clotting. It can affect blood clotting and lead to anemia also. The number of side effects of these chemicals are very diverse. Some of them you will study on senior courses. Some of them you'll have to study yourself. The choice is yours. Pollution of lithosphere, of course it is interconnected with the pollution of hydrosphere, because this water which we pollute we use for watering our plants, yes. Chemicals also accumulate in the plants and go to our table. And we also use pesticides, herbicides, fungicides, because we don't want anybody to touch our harvest. All these things also accumulate in plants and travel to our bodies. Soil pollution. We discussed that pollution also causes, for example, fly activity. We studied flies last class with you. And chemicals from soil diffuse and spread on a few kilometers. They go inside of the walls of our houses and evaporate in our flats and houses. They penetrate inside of crops. They go in the grass. Which our cows and sheep and goats eat, and then go into milk which we drink. Yes, they go in the eggs of chickens. And eventually they again come into our body. So very beautiful apples, very beautiful fruits, yes, which look like plastic. They can be dangerous because they can contain lots of pesticides, herbicides, and many people, many rich people, they pay huge money for organic food. So why organic food costs so much money? Because it takes lots of effort. It is very expensive to grow nowadays food without modern chemical fertilizers. And by the way, more we cause erosion of soil, yes, more chemicals, more fertilizers we have to apply, more toxic food becomes. So more and more we do this, more our food become toxic. That's why organic food, which is very popular in the rich people, costs huge amount of money. Of course you should eat fish, of course you should eat fruits, vegetables, but please try to make at least some assurance that it is grown at least in clean area. And in winter countries, if you live in winter countries like Russia, try to eat seasonal fruits. If you go to shop and buy strawberry in December, of course it doesn't grow in December, of course it's grown somewhere else and can contain lots of chemicals. So try to eat fruits and vegetables according to season. I mean, if you live in our country. Okay. Garbage. More and more, you know that we produce huge amount of garbage. More people we have, more garbage we receive. And now everything is packed in the plastic boxes, in the plastic covers, etc. And the amount of rubbish which we produce is huge. So where does the rubbish go? Does problems of making garbage is very huge for many countries. Russia, India, Nigeria, Egypt. Yes, more larger city is, more hard to utilize all this garbage. So it is taken to huge garbage polygons, and all these chemicals go again into soil, into water, and in the atmosphere. So what we should do with this garbage? Is it possible to get rid of it? Yes, of course. Many countries start to think about rubbish policy, and some countries like Norway and Sweden, they start to recycle this rubbish. And instead of this, they have nice clean areas. And they so succeeded in the recycling of rubbish that they buy rubbish for recycling for another countries. Nobody asks to come out. I don't ask you to come out and clean the garbage out in nature. Many people spoil the nature by throwing plastic bottles. You know that plastic bottles decay more than 100 years, even more. So please, no, if you don't want to clean the nature, it's okay. Just don't put rubbish when you go out hiking. If you brought plastic bottles with you, take them away from the forest and put them in the proper places. If you want to care about nature, you should know where plastic bottles, where batteries at least, yes, some waste products are recycled. Many countries, even Russia of course, it has containers for rubbish, for plastic bottles separately, and at least these small things, if you don't at least put rubbish, they will still help nature very much. Because if you put rubbish everywhere, one day you will come and you will not find any clean space simply in the forest. It will not be possible. Air pollution. I think you all know what is air pollution. We have a huge amount of chemicals which are emitted in the air, starting from car exhaust gases, yes, starting from rubber particles, which come from tires, every day, different exhaust gases like nitrogen oxide, which come from burning fossils, carbon dioxide, carbon monoxide, different chemicals which come from heavy industries, from heavy enterprises. They all come to the atmosphere, and more people live, more people are present in the place, more amount of gases are accumulated in the atmosphere, more heavy you can feel that your body is suffering from the lack of oxygen. So when you walk in a big city, you become tired very quickly. If you travel, for example, even here seaside, you can walk 5 kilometers, yes, you young people, and you will not feel any tiredness. Why? In Simferopol, for example, in the center, you start to feel very quickly headache, you start to feel lazy, and in seaside you are very active, you are very happy, because the amount of oxygen in the atmosphere, more oxygen is present in the atmosphere, more active your body feels like, and it is true. So number of oxygen in the cities, especially in the mega cities, megapolises, diminishes dramatically. The normal amount of oxygen should stand at 20-21%. In mega cities it stands 18-19% only. That's why people feel tiredness, feel discomfort, yes, feel depression, because of the amount of oxygen. And of course chemicals, different gases which are dissolved in the air, they also travel to our body through the skin, through the lungs, and they cause asthma, they cause bronchitis, and they induce lung cancer. One more thing about atmosphere. We have ozonic layer which protects us from sun radiation. I think you know very well from school. And this ozonic layer is very actively ruined nowadays by industrial activity. When spaceship goes up and down, especially when it launches, yes, when it comes back, it ruins up to 0.3% of ozone layer. More ozone layer is ruined, more radiation becomes aggressive, more chances of skin cancer we have. So if you spend whole day under the sun, yes, without protection, without clothes, if you even have dark skin, you'll be in trouble. If you will have white skin, after a while it can result in a very bad consequence like melanoma. So sun becoming dangerous more and more every year because we ruin our ozone layer. One of these aspects. And of course you heard about greenhouse effect, yes, about changing of temperature on our planet. Some people say because of exhaust gases, some people say it's natural cycle, but still you can see that climate is changing actively. Yes. Please pay attention to this picture. What is happening here? This is so-called event called smog. This smog is mist which contains different dust particles. It looks like fog, but it's not made of water droplets. It is made of dust particles. So this is smoke in Delhi. And all people have to breathe these dust particles. God knows what it is made of. And point attention to this guy. This guy is motor rickshaw. He drives people every day on crowded places. Yes, and he breathes this smoke, these exhaust gases from cars every day. How long do you think he will live? Such people who breathe such air, they live 30-40 years, maximum 50. That also concerns people who work on heavy industries, no matter in which country they live. So if you are very rich, but if you drink polluted water, breathe polluted air, live on polluted soil, eat polluted food, you will not last long. This you need to understand. Will you agree with me or will you disagree with me? More people will understand that we should not pollute the planet, more better our life and health will be. Is it possible not to pollute the planet? Yes. Green technologies are available. What is the problem? What is stopping people from using them? Their consciousness, because they don't think it will concern them. They think it is something scary fairy tale. But it is here, it is now, it affects all of us. So young people like you also exposed, unfortunately, in all countries to the harmful biospheric activities. According to the past years' research, the number of healthy school children all over the world makes only 29%. So only 29% of children which go nowadays to school are relatively healthy. Not very healthy, but okay, yes. In 1977, the amount of healthy children was no less than 33%. So nowadays amount of healthy children is reducing. 85% of women which give breastfeeding to baby, in their milk we found pesticides. So 85% of neonates receive breast milk containing pesticides. And here you see the number of cancer cases. number of cancer cases, yes, and you see that number of people who, young people, healthy people, beautiful people like you, who should have all life ahead, who should enjoy, who should learn so much, who should see so many beautiful things, unfortunately are having cancer. How this cancer program is activated, nobody knows. Maybe also by some environmental agents. And of course, people who live in the polluted cities, they have different respiratory problems, and very often we find asthma in young children too. Many people, they come from village, they come to big city, they want to find opportunities, and instead they find asthma problem because of different allergens which are present in the dust of the modern cities. So point your attention on these pictures. And think maybe at least for 5 minutes today about what is healthy environment. What are we doing to our planet? Because if you will not have environment around you, this is our next topic, ecology, your life will not be possible. Okay, and biosphere. After biosphere, we straight away come into ecology. Ecology actually contains lots of different branches of sciences. We will just mention very small aspects of ecology, just for general program and for your exam too, and for your understanding of how we should live too. What is the problems which are happening on our planet? So what is ecology? Ecology comes from the Greek word oikos. Oikos means house, yes, and ecology is the study of interaction between living organisms themselves and between living organisms and their environment. So the interactions between biotic and abiotic compounds. So the key word which studies ecology is how we live together. It studies the relationship between organisms and their environment. I think it's not very hard to understand. The term ecology was introduced by Ernst Haeckel. If you remember what is biogenetic law, you'll remember this name again. Yes, German scientist, and he introduced this term ecology. So levels of organization which are studied in ecology. When you came to first classes, it was October for most of you, we studied from this level. And today we traveled all this way and already came to this level. So time goes, and you can compare yourself when you first came to biology class. Most of you say, oh my god, where did I come? And you can see where you are now. Who made progress, who still don't know the cell. Yes? So if you understand what is ecosystem, if you went all the way through, that means you spend this year with getting some knowledge, and it's very nice. So what ecology studies? Ecology studies organism, which requirements for environment organism needs, how it lives, how it reproduces, how it interacts with another organism, which factors does it need. The branch of ecology which studies the needs of particular organism is called haute ecology. Then ecology studies also organisms at population level. It is called population is the group of organisms which occupy specific area. These organisms should belong to the same species. They should have free reproduction and be relatively isolated from the other populations. So they need to have specific territory. I remind you, because today we have classes on evolution. Tomorrow also, this week we'll have evolution, and we'll again talk about population. Populations, Populations of different species form communities. Branch of ecology which studies populations and communities, for example, communities of plants, fungi, animals, is called synecology. Synecology, syn means together in Latin. And when we place community on the certain part of abiotic nature, when community starts to interact with abiotic nature, they form biogeochemical cycles, they turn into ecosystems. Yes, big ecosystems which unite together on relatively similar territory, like big lake, are called sometimes biomes. And all ecosystems on our planet again are united in the biosphere, living part of our planet, which I just told you about. So basic terms of ecology are organism, population, community, ecosystem, environment. What is environment? Everything which is around you, everything which is around you is environment. And here again we come to the basic law of ecology. We come again to the basic law of ecology, Sechenov-Rullier law, which says that organism cannot exist without its environment. So basically, most of ecology is based on this simple but crucial law. Organism cannot exist without its environment. If atmosphere will go around you, what will happen? You will die after 5 minutes or even faster. That's all. So environment is all sum of factors which are affecting particular organism. It's very simple. Environment consists of many factors. These factors are divided into 3 main groups. First is factors of abiotic nature, non-living factors. Second are factors of living nature, of living organisms. And third are anthropogenic factors. Which are classified actually into positive and negative. It's very small classification, and of course they can be different by nature, physical, chemical, biological, and social. When we interact all together, when we stay in the group, we also have ecological relationship, yes, and it is called human and social ecology. Some parts of social and human ecology basically, I will also mention today. It's very, very interesting. So again, environment is sum of factors which surround the organism. All factors which are present around the organism. It's environment. Everything which is around you. Factors which are present in the environment. Abiotic factors, non-living biotic factors, interactions between organisms, and anthropogenic factors which are imposed by humans. So abiotic factors, I think you all know them from school. It's not very hard to understand. It's a temperature. Yes, now you're all affected by temperature. Climate is a very common factor which we still cannot manage. Yes, which affects all of us. The sun goes up, sun goes down, temperature rises, temperature goes down, clouds come, rain starts, etc. It all affects our health, our mood, even everything. Sunlight, amount of sunlight, soil composition, water composition, air composition, amount of oxygen, yes, pH of water or soil, for example, altitude above the sea level, etc. So these are the main abiotic factors which affect all living organisms. And the factor which affects human nowadays the most, we try to hide in our artificial technosphere, but still we are affected, is called climate. Limiting factors is very important term of the factors, which you understand that factors can be limiting. Limiting factors, the factors which are essential for the organisms, and if they are not present in a big amount, if they in essential amount, they limit growth of the organism. So limiting factors, they affect the carrying capacity of the organism, of the organism population. For example, if you have plants, limiting factor can be amount of sunlight. If you have animals, limiting amount can be oxygen level, etc. So some important factors, yes, can be called also as limiting factors for living organisms, which restrict their amount multiplication inside the population. So if something was once alive, yes, it belongs to biotic factor, and biotic factors, they are also very diverse. They're also very diverse, and they are very, very important. So biotic factor are imposed by animals, plants, fungi, protozoan, and bacteria, and of course vira. All of us now are affected by viral factor, yes, whether we want it or not. This is example also with ecological interaction. Before we talk about classification of biotic factors, we need to mention what is organism niche and what is organism habitat. What does organism needs according to ecology? So habitat is actual place, actual part of the environment where organism lives. So this is environment, this place is habitat. It can be big, it can be small, and it is classified according to their physical conditions into aquatic, most stable, terrestrial, most diverse, and aerial, yes, like birds, they live in the aerial changeable habitat. And of course one habitat is not mentioned here. It is organismic habitat. Many parasites, they don't want to fight with air, they don't want to fight with seasonal changes. They have chosen very comfortable organismic habitat inside of our bodies. We spend whole semester mostly on parasites. I think you have enjoyed it. Oh, I'll not mention. So habitats can be aquatic, terrestrial, aerial or arbor, and of course organismic. Niche. What is ecological niche or niche? This is organism role in the ecosystem. So every organism has its own job and has its own requirements where it can live. Where it can live. So organism job in the ecosystem, yes, and some of requirements to particular habitat, how much moisture it needs, how much sunlight it needs, which kind of food it needs, is called ecological niche. Because organisms are multiple, yes, they cannot live on their own, yes, many organisms compete for the territory, they have to share same niches, and if they want to settle there and form ecosystems, they need to follow their job recommendations, they need to run their programs, and according to their ecological role in the niche, organisms are divided into producers, consumers, decomposers. These are three main roles in the ecological niche. I think you know it very well from secondary schools. Producers of course are autotrophic organisms which are able to make their own food. Who are these organisms? All organisms which are able to do photosynthesis. All organisms which are able to run photosynthesis. All green organisms. This can be plants, this can be algae, this can be phytoplankton. Once they make the process of photosynthesis, they store glucose, yes, by chlorophyll, and this glucose is passed further to consumers by the trophic chains. Yes. So the rest of organisms, a part of human, yes, human too, of course, they get all energy consumers only by food which is stored from green plants. Consumers are heterotrophic organisms which cannot make their own food. Yes, they need to eat the food from the other organisms. They are classified into herbivores, yes, like cows, sheep, goat, which eat plant food, the vegetarian people; carnivores, which take the food by eating herbivores, yes, because they cannot get protein directly from the grass, and the herbivores can actually. Omnivores, which eat both animal origin food and plant origin food, like bears, of course, and of course the scavengers which feed on dead material. So these are consumers, and humans are also consumers. So these are scavengers. Of course, you know that so many flies are scavengers, and that's why they deliver eggs, they deliver cysts, bacteria, vira from decaying matter to our houses. I told you, yes, synentropic flies, you know them very well. But without decomposes, our biochemical cycles will be incompleted. Yes, so cow eats grass, wolf eats cow, dies, become decomposed, nitrogen goes back in the soil, and from the soil grass grows again. This is very simple food chain and very simple life cycle or biochemical cycle of nitrogen. So energy in the ecosystem is obtained by producers. Producers get this energy from the sunlight. Yes, they can take only 1% of sunlight which is emitted upon our planet, and even this 1% of life cycle allows them to produce 170 billion metric tons of food each year. So plants and green photosynthesizing organisms are extremely productive. So food chains. I already mentioned what is food chain. So for example, I mentioned it once again, definition, so you don't get confused. So food chain is a series of relationships between the organisms according to trophic levels. When from one trophic level organism passes the energy to the another trophic level. So food chain is the flow of energy between the trophic levels which are formed inside of ecosystem. So this is a passage of trophic energy. Trophic levels are different feeding levels of ecosystem. Producers make the largest first trophic level, yes, and consumers, they can be secondary, tertiary, quaternary, yes, quite a lot of them can be possible. They make further trophic levels. Their graphical representation of trophic levels, yes, in the decreasing order, it is called ecological pyramid. So graphical representation of trophic levels in the ecosystem or in the food chain is called ecological pyramid. It's also very easy to understand. So ecological pyramid can show three types of information. It can show energy, it can show number of organisms, and it can show biomass. So how many biomass was present in the first level, third level, fourth level. So ecological pyramid, again I tell you, it starts from autotrophs, yes, then it goes to herbivores, carnivores, and can finish with decomposers. This is grassland type of ecological pyramid, or grassland type of food chain, when we start from fresh green producers. And we have also detried food chains when we go vice versa, when we start from rotten rotten produces. Then these rotten produces are eaten by decomposers, for example worms. Then we come to consumers who eat these worms, for example birds, and then we go to predatory birds which eat the worm-eating birds. Yes, so there is two types of food chains which are possible in the wild nature, in the ecosystem. First is grassland food chain. It can also be present in the ocean and start from phytoplankton, and it can be detritus food chain when we start from decaying green material. It's not very hard to understand, I think. What you need to know about ecological pyramid: that ecological pyramid is built according to the 10% law. This is key law to understand how ecosystem is run and how ecological pyramid should be built. So when we eat something, 90% we use for metabolic wastes, and only 10% will be stored in our body as biomass or as a reserve for energy. So 10% law. 10% law says that from one trophic level to another travels only 10% of energy, and this 10% of energy can be stored on another level. Because we have 10% law, our food chains and ecological pyramids are not very long and not very high. What does it mean in the practice? Here you can see a pyramid of energy, a huge amount of plants, for example. Yes, 10 kilograms of plants can feed 10 grasshoppers. 10 grasshoppers can feed 3 mice, and 3 mice can feed only 1 snake, for example, per month. So this is how 10% law works. Why we need to know this law? Why we need to understand this ecological pyramids? Very simple. To make big amount of producers, for example, which can feed up to 10 snakes, we need to have very big territory. And if territory become short, small, reduced by human activity, animals simply do not have food. They simply run out of food because producers cannot grow on this area. If we remove this level, all these levels also start to break. One level you remove, like in a puzzle, everything starts to break down. So many people say, oh, why these animals disappear? We didn't kill them. Yeah, you didn't kill them, but you took their land away. If you took the land away, if you took territory away, producers are gone, yes, and consumers will be gone too. So when people build natural parks, yes, they want to store some nature, they measure the area of these reserve parks according to these biological pyramids and according to this 10% law. Okay, so from one trophic level to another, it can travel only 10% of energy or biomass. So this is how energy ecological pyramid looks like. Yes, in joules. This is biomass pyramid, pyramid. This is number pyramid. So for example, per 1 month, yes, 10 mice can feed only 1 owl. But for these mice to grow, we need a very big territory of producers initially. This is how food chains and ecological pyramids are being designed. Food webs. Food webs is a kind of food chain, but it is little bit more complicated. So food web is a network of food chain which is present in the large developed ecosystems. Why it happens? Because many organisms can participate in the different food levels too. Okay, more food webs, more food chains we have, more these relationships are diverse, more stable ecosystem is. More stable ecosystem is. So ecosystem stability is run by two main factors: diversity of organisms and intensity of biogeochemical circulation. More biogeochemical circulations are present, more intensively they go, more rapidly they go, more stable ecosystem is. If one cycle starts to break down, start to stop, ecosystem will start to break too. And again, I go back to concentration of pollutants, or what we call biological magnification, yes, in the bodies of the organisms. And again, for example, I can give you DDT example. So DDT is one of the first pesticides which was initially designed to find malaria-carrying mosquitoes. And because many mammals and birds feed on mosquitoes, this DDT accumulated hugely inside of their bodies, yes, and affected their reproductive abilities. From birds and animals, it went also by food chain entire human body, yes, and accumulated there. And because of this chemical accumulation, which initially was found to control mosquitoes, bad mosquitoes, led to extinction of many bird and mammal species. So biological magnification says if the organism stays on the upper trophic level, if this organism is a predator, yes, the toxins amount of the predator body can be very high, can be extreme. So another example of how DDT chemical goes and kills the body of different animals, how it travels from one animal to another by food chain, is rainy cats. Yes, that when people applied DDT on houseflies, it led to their cat disappearance because of food chain. Yes, and after that, Borneo authorities had to even bring cats additionally because the island was overtaken by rats. So if we break one part of food chain, yes, other parts of food chain will break down too. That's why when people say why we cannot kill all mosquitoes, they're very bad. Yes, they're very bad, but if we kill them all, our amphibians, our reptiles, our birds, many mammals will disappear simply from this planet. So mosquitoes should be killed only in the certain areas and controlled by certain ways. So from practical use, for example, when you go to shop and want to buy predator fish, yes, you need to know zoology a bit. For example, like tuna, the amount of mercury inside of this fish can be very big because this fish is predatory, and many small fishes, yes, donate year by year mercury from their bodies. Where mercury comes? From pollution of the world ocean. Okay, relationships between organisms still continue. So again, biotic factors can be classified according to a ecological niche. It can be producers, consumers, decomposers. Yes, these relationships go further in the food chains, food webs, and represented by three types of ecological pyramids. And other parts, other interactions in the ecosystems, other biotic factors in the ecosystems, a part of niche, are divided into predatory, inter-competition, inter-symbiosis, and inter-mutualism. So, predator-prey. One organism, predator, hunts for prey. Yes, it's very simple. Competition. Organisms do not eat each other, but they compete for territory. They compete for territory or water, yes, or food, etc. Parasitism. Parasitism, mutualism, commensalism belong to symbiotic relationship. So when organisms live together, yes, very closely to each other, not just share some territory, but very closely. They go into these three interactions were called symbiotic. Symbiotic means living together. And symbiosis is not always good, actually. So mutualism, when one partner helps each other. Yes, you passed your submodule test and took your phone of your friend to submit tests instead of him. Yes, when teacher doesn't see you. A friend gave you chocolate instead. This is symbiosis, very simple. It's mutualism, sorry. Parasitism, when one organism uses the host organism for food, shelter, and damages it. I told you 300 times what is parasitism. I'm not going to tell you again. Once only. Commensalism, when one organism benefits from another. Yes, commensal benefits from another. Yes, houses inside of this organism, or lives in the shelter or takes food and doesn't harm the host. So it's called commensalism. For example, Entamoeba coli is not good, is not bad. It inhabits your intestine for food and shelter. So this is competition. Yes, we learned that competition is the running mechanism for struggle for survival, also evolution topic. This is predation. Predation also is the factor of evolution because it causes population waves, population size. Yes, it affects population size. Population size is non-direct factor of evolution. Please remember for today. This is, what is this? This is mutualism. It is mutualism. Bee takes nectar from flower, yes, it's food substrate of bee, and instead it pollinates the surrounding flowers. Clownfish and actinia. Clownfish and actinia. So clownfish hides inside of actinia, which protects it from many natural animals. Okay, commensalism. This seahorn is attached to whale, yes, to get food, shelter, and to travel around. And parasitism. I think you can give many examples, maybe better than me, because most of you, I hope, already became experts in parasitology, and it's very good and useful skill. Many people are affected by parasites nowadays. Pollution of water doesn't mean always pollution, for example, with chemicals. Yes, it also means pollution with bacteria, vira, and parasites too. Changes in the ecosystem. Ecosystem has its own cycles. It doesn't stay always the same as it was before. So ecosystem changes within the time. I remind you that ecosystem is the basic unit of ecology. It consists of abiotic compound, yes, part of nature, and biotic compound, community of living organisms. So if we take a park, for example, yes, it can be called kind of ecosystem, artificial ecosystem, and we have territory of Gagarin Park, specific territory, and we have animals, squirrels, birds, we have plants, we have fungi, yes, we have bacteria, and all of them live together in this park. If this park exists, that means ecosystem is going on, yes, and sooner or later it will undergo changes. Sometimes it can be quickly changed, sometimes it can be slowly changed. Changes in the ecosystems are called succession. Ecological succession is the process when the communities in the ecosystem changes over the time. Succession can be primary and can be secondary. Primary succession is when community of organisms appear on the brand new piece of land. For example, volcano had eruption, lava came out, formed volcanic island, and it's just a brand new piece of geosphere, yes, of lithosphere. After a while, on this island come bacteria. They come everywhere and appear first primitive forms of life, which are called lichens. You can see rocks in Crimea. Trees are covered by different colorful spots, which are called lichens. Lichen is symbiosis between fungi and algae. So these lichens produce acids. Acids ruin the rock, the mineral rock. Rock forms dust, and this dust is mixed with the parts of lichens, forming very thin layer of soil. Very thin layer of soil. After a while, birds bring seeds. Accidental birds bring seeds of grass, and on this island appear grass. Grass breaks the rock even more, and then come shrubs, primary shrubs. After shrubs come fir trees, and after fir trees come leaf trees. When leaf trees, shrubs appear, animals, birds, mammals eventually start to come. The primary successions nowadays are very rare. They appear only after volcanic eruption, and most of these primary successions are restricted because scientists come there and observe how life appears. They help to understand the evolution of our planet. So primary successions are almost never found today. Secondary succession are much more common. Secondary succession is when new community appears on the place of existing one. For example, we had abandoned farm, yes, and after a year, this abandoned farm turned into grassland and in the young forest. And vice versa, forest was growing, fire happened in the forest, trees got burned, and it traveled, came back to their grassland. Lake in the forest accumulated lots of organic material and turned into swamp. Swamp accumulated lots of organic material and turned into dry land. So this is a secondary succession. So what you need to understand that every ecosystem has its own periodization. After succession, it tends to develop. It tends to grow more biochemical circulations. It tends to have different biological diversity of communities, and when ecosystem reaches stable state, yes, when all biochemical cycles are working properly within biotic and abiotic compound, it is called climax. Maximum stability, maximum development of ecosystem. And once climax is reached, ecosystem can go again for succession. So this is how it works. How it happens, very easy. More forest is larger, more amount of dry materials it has inside, and more easier it can get burned down. Yes, by lightning, for example, or accidental fire. After general ecology, I hope you understand the basic terms of general ecology, which you need to know in our course. Of course, ecology is much more complicated than that. We have ecology of cities, we have ecology of fields, of agriculture, of rivers, of lakes, of different countries. But for your program, I think it is enough. If you want to know more, you can always read and watch more. Yes, nobody pushes you and restricts you only in our lectures or in our books. There is many more information which you can read if you are interested more. And we come for the human ecology. In the biosphere, I told you that human is the most powerful and driving geological force of today's. A human, according to Vernadsky, was supposed to understand planet, to turn it into noosphere where it peacefully coexists with the natural laws. But human thought he is the master of planet. Most of people thought like this, and turned our planet instead of noosphere into technosphere. What is technosphere? I showed you in the pictures. I'll show you even more. Anyway, human position in the world is very important. And in the beginning of the 70th years of the previous century, was formed science which is called human ecology. which studies the position of human in the modern nature, which studies interaction of human with the other organisms, which studies interaction of humans between themselves, which studies adaptation of humans, which studies human-made ecosystems, yes, and human impact on the environment. So it's very, very interesting science. So the main aspects, the main targets of human ecology. First is a focused upon of human population. So human population can be affected by limiting factors, yes. So for human populations experience following limiting factors, which is lack of food, water, space, or any other necessity, for example, economical state. You can see that human species Homo sapiens are now in the biological progress, yes, and amount of people nowadays make 7 billion and is expected to rise more to 10, some people say up to even 12 billion. So if these limiting factors will be overbroken, human population will rise even more up. So here you can see the population projects, how much increase world population will experience from which countries, and you can see that the leading country which will actually supply population to the world will be India. According to the recent prognosis, yes, India might overcome China by population in the recent years. Though number of people is growing up, yes, the number of children is slightly reducing. Why slightly reducing? Because the number of children which can survive nowadays is getting also high. Long time ago, people used to have 12 children, 10 children, because most of the children died before puberty. Nowadays, because of level of life, most of children survive. So number of children in population in humans in most countries is now being reduced. Another tendency for human population. Most of people want to live in the big cities. Because of modern economical situation, and economical situation is similar and way of life is similar in most countries, which is called globalization nowadays. Many people want to find opportunities in the big cities. And now we have tendency for mega cities, yes. So many people try to live in the big cities, and the amount of urban population increases almost to 5 billion. So if we have approximately 7 billion now, 5 of this billion, yes, 5 of them live in the big cities. Rural area become abandoned more and more. Making a big city creates big problems. So we have ecology of city, urban ecology, which tries to use proper land planning, which use properly taxes, city zoning, that we have areas for rest, for nature, for parks, yes, for industry, that industry should not be placed in the city center, for smart growth, yes, how many citizens, how many houses can be placed in the city, yes, boundaries, green belts, etc. So more city is big, more problem it experience. And when you come to big city, you always feel that this is the rhythm of big city. It makes you very stressed. What is stress? I'll tell you also today. So does the life in the cities make us happy and healthy and good? More people, more competition. I told you this is natural selection. So most of people are poor. Some people say, some students say, oh, I'm unhappy, I'm depressed, I'm something else. You are very happy people because you have access to water, to knowledge, to food, to gas supply, to light. Many people in this world live less than $2 per day. I think you know it better than me. Many people are still illiterate. Many people, 1 billion, live in slums. They don't have proper houses. Many people cannot have access for clean water. They know that this water is harmful, but many of them cannot have access for clean water, and the amount of fresh water is decreasing because of industry every year in many countries. So if you think that you now sitting and watching me are unhappy, poor, there are people who are much more unhappy and poor than you, and the number of poor people who don't have enough food supply, enough water supply, enough electricity, who have no chance in this life except of hard work, this number of people is increasing dramatically. So please take knowledge and use it, because you are given such chance. You should use all chances which you are given. It's a very great gift to you. Okay, this is philosophical issue. I will not waste my time on it. I think you are adult people, you make your conclusions after this lecture. Our every lecture is my message to you. I hope you get me right. So, food crisis. A part of environmental pollution, a part of stress, a part of rhythm of big cities, we also have food crisis. You go to the shop, you see plenty of food. What does it mean, food crisis? That we have hidden hunger, hidden famine. That many people, they have access to food, they don't starve to death, but most of these people receive food which doesn't contain enough vitamins, enough nutrition. So if you eat all the time rice, you'll not die from hunger, but you will have protein misbalance. Yes, so many people receive food, but this food does not give them enough microelements, enough vitamins, enough proteins, enough fats. Yes, and they suffer from undernourishment. Hidden food shortage. So these are ecological examples of ecological crises which many people, populations go nowadays. And now we are coming to anthropogenic factors, which human as anthropogenic factor, as environmental participant. Most of human activities are negative. So what human does with the environment, most of it has negative impact. So first of all is reducing diversity of species. So human does overhunting, overfishing, you know what this means, capturing wild animals, yes, and poor land management. So when human comes, it cuts trees, yes. Many people don't know how to run agriculture properly, and land simply becomes deserted. So mainly human population grows, it needs territory, it needs resources. It comes to wild land, takes piece of wild land, try to use it. Either human builds cities there, either human makes agriculture, and if something goes wrong, this land becomes abandoned and cannot be restored. That's all. If you take land from animals, they either die, either they have to find new place. They have to travel somewhere else. If they don't try to travel somewhere else, they try to adjust to humans like monkeys in your cities, or they simply become extinct. Every year one species of mammals become extinct, yes, and 120 species nowadays are under threat of extinctions. In few next years they will be extinct too. Same concerns birds, plants. It all happens to human activity. When you take land from somebody, they have to find new land or die. Most time they die. So this is what happens to our neighbors, what we do with our neighbors. Okay, pollution. Pollution can be done not always by releasing chemicals, but many people bring new species. When people travel, they can bring new species accidentally or specially. For example, when people sell fruits from one country to another, many pests, many insects can come with these fruits and start to damage fruits which are present in their new house. For example, Australia brought rabbits into Australian continent. What happened to Australia after they brought rabbits? Rabbits didn't have natural enemies. They didn't have population size control. They start to multiply in enormous number. They ate all grass. Everybody, kangaroos, koalas who ate grass, other animals, they start to suffer. So this is negative human activity. And of course pollution. Pollution does not always affect us. Like I showed you in biosphere, it also affects our animals. If you don't take their land, if you don't cut their trees, if you don't bring foreign species, but if you live and pollute the air nearby, they still suffer. This you need to understand. They still drink this dirty water, they still breathe this dirty air. They still become extinct because of that. So water pollution, dumping of chemicals, pesticides, fertilizers, detergent from your washing machines, etc. And another interesting example of pollution is decrease of oxygen because of extreme multiplication of algae. These fertilizers which go to the water from our fields, they don't all accumulate in the body of fish. Some of them initiate growth of algae. Yes, and this what happens in China, for example. Yes, so this happens because of emitment of fertilizers in the ocean or in the sea. This you saw how it comes, you know. And I told you that pollution leads water, for example, leads to increase of the amount of parasites in the water, amount of bacteria, vira, and thermal pollution. Thermal pollution increases the temperature of water, and many species become extinct because they cannot adapt to such hot water. The changes which humans make in the environment are very rapid, and though life can adapt, some species adapted to life with humans. Most of them simply do not have time to adapt and simply become extinct because of evolution. Sometimes it goes quite fast, but in most cases it takes time. So they simply do not have chance to adapt to human activities. Air pollution, I told you. Sulfur dioxide, yes, which leads to acid rain. Acid rain is formed in your city, and wind blows this cloud to somewhere else. Yes, you made it and others suffer. Smoke. What is smoke? Accumulation of dust particles in the atmosphere. And temperature changes. Yes, temperature inversion. This you know very well from school program. If you don't know, I'm telling you. And by the way, if you will read world politics, you can see that many countries like to put harmful enterprises in Asia, in Africa, in Russia too, because they don't want to pollute their own environment. They use your territory for such negative processes. And of course cars. More vehicles you have, more air is polluted. More people you have, more cars you have. This is the example of greenhouse effect, temperature inversion. When hot season comes, cities become very hot. If you compare summer temperature in city or in village, village is much more cooler than city, because cities can accumulate heat, yes, in their concrete houses, in their concrete sidewalks. Here you can see the deaths from pollution of air. I told you, you can be very rich, very nice, very smart, but if you live in the polluted area, in a heavy polluted area, your lifetime will be short. So this is amount of people who die from lung diseases which are associated with air pollution. Land pollution, I told you, garbages, pesticides. Land pollution is also linked with the atmosphere pollution, water pollution. All these pollutions are interconnected. So when you have too much rubbish, if you don't recycle it, you burn it. All things which you burn, all these chemicals are emitted in the air, and by wind they come back to your city. About pesticides, I told you, yes? Food chains, more and more. And I told you, more land we use, more it becomes infertile, more pesticides we have to use to make it produce at least some harvest. If we don't run the agriculture properly, our land simply become non-fertile, it turns into desert, and it is called desertification. The number of deserts is growing nowadays, and existing deserts like Sahara, Namib Desert, they are growing in their sizes. So number of deserts is increasing. And of course, because people start to understand after being mistaken, after paying big price for their mistakes, as always, like some students who start to study only when they get in trouble. Yes, some of you do. They start to make some positive anthropogenic aspects. So pollution, desertification, decreasing of species diversity, these were negative anthropogenic factors. And still we have possible human activities. Many people start to preserve the natural resources. So recycle rubbish, use instead the energy of fossils, renewable sources, air, sunlight, geothermal energy, water energy, hydroelectrostation, for example. Recycling of rubbish, of course, it's very, very helpful, and most of rubbish is possible to recycle. Many people start to understand, start to refuse from excessive clothes, excessive materials from cars. They start to understand that human doesn't need much things for life, for good life. Yes, and excessive things are not required in this life. Most of clothes which you see in the shop, most of these clothes will go to garbage because nobody will wear it. Conservation of soil, planting trees to prevent erosion, reforestation to bring back oxygen to the atmosphere, wildlife conservation, yes, to bring to save species which are going to extinction. Though it doesn't help much, but still, this is example of soil conservation. Green belts, they slow down soil erosion from wind. Reforestation. Pollution control. When we talked about methods of mosquito control, I asked you about biological method, and my brilliant students Adeniki and Nikita made very good report about biological method of mosquito control. Biological method is not only used for mosquito control, it's also used for tsetse fly control, some other parasites, and these biological methods are very effective. And what is important, they don't harm the surrounding species, they don't affect surrounding nature, like DDT, for example. If you want to learn more, please go back to Malaria Roundtable and watch their report. So using natural enemies of the pests, yes, is more preferable than using chemicals. So these are different pests which can fight with our parasites. And of course, we can use crop rotation. Yes, we can use genetics, make sterile pests which do not produce offspring, etc. So pollution control by biological methods, of course, is possible. More and more people, fortunately, are paying much attention to our environment. And you are the future of your countries. Of course, you're here to bring better life to your countries. And I'm very happy that I teach you your future, your further generation. If you understand and if you teach other people how they should live, if all billion of people would take at least one small rubbish box, your countries will be very clean and very comfortable to live. And maybe buy it too. Okay, adaptation of humans. Human ecology doesn't study only people population, people factors, anthropogenic factors. It also studies human adaptations to different climatic environmental zones. First thing, very interesting thing about human ecology is human ecotype. Human ecotype is nothing to do with race, nothing to do with nation. It is evolutionary formed adaptational program of human body according to specific climatic zones. So humans occupied almost all areas of our planet. Some of them live in the temperate zone, some of them in the Arctic zone, some of them live in the hot tropic zone, some of them in the desert zones, some of them settle high in the mountains. And according to their historical settlements, due to evolution, human evolution also happens nowadays. It led to formation of certain ecotypes. So human ecotype is evolutionary adaptation to the certain climatic conditions. First is Arctic ecotype. Some people all the time live in the area, or most of the time live in the area with extreme low temperatures. Some people live in the area where temperature can go beyond -50. Arctic people have specific adaptation to these conditions. This is increased amount of body fat, increased amount of cholesterol in the blood, increased amount of bone marrow, increased body mass. Arctic type of people, these people who inhabit this Arctic region, who are used to live in the cold temperatures, and main food ratio of Arctic people make fatty foods, meat and fish. Arctic people, they might never eat an apple during their life, but though they live all their life eating fatty foods, they never or almost never have atherosclerosis. They are fully adapted to extremely fatty foods, and if they don't have fruits and vegetables, they don't suffer from it. If they start to eat fruits and vegetables, some of them, they even become sick. So Arctic people are people who evolutionary adapted to extremely low temperatures, who live mostly in the ice and snow, who eat fatty foods of animal origin, and have specific adaptation, like increased layer of fat on the skin, increased amount of bone marrow, yes, increased level of cholesterol, and they're fully adapted to this fatty nutrition. Tropical ecotype. Most of you who listen to me, you belong to tropical ecotype because you live in the hot, humid areas. So tropical ecotype, if you look at mirror, you can see the features of the tropical ecotype. These are thin people with small amount of fat, with dense hair, with thin elongated bones, with low body mass, with sweat productivity, and these people are very nicely adapted to the food which is enriched with carbohydrates. So most of you are vegetarians, and you feel absolutely fine with this food. If you eat small enough amount of protein, of course protein is essential for you, but small amount of protein is enough, it's fully enough for your ratio. So this is tropical ecotype. If you will, what you need to know about these ecotypes, if you will come, for example, to cold area and start to eat fatty foods, yeah, you can eat fatty foods for some time. But if you will have too much cholesterol in your bloodstream, you will grow atherosclerosis much more faster than Arctic or temperate people. So overeating of fatty foods for your ecotype, especially when you come here, when you don't have food diversity, can be extremely dangerous. So when you want to get some food, yes, please be very careful with fast food, because you will get body mass and problems with health very quickly. Mountain type of people. Mountain type of people are adjusted to live in the highlands. These people who live in Himalaya, for example, people of Nepal, they can go Mount Everest. You can see in movies up to 8,000 kilometers quite easily. So 4,000 kilometers, 5,000 kilometers for them, it's okay. If you go 3,000 kilometers without preparation, most probably you'll die from mountain sickness. But these people have increased chest capacity, increased lung capacity, and increased amount of erythrocytes in their bloodstream. So when people do blood analysis and you see increased amount of erythrocytes, you need to check where this person came from. If he came from mountain place, that means his analysis is normal for him. And the most common type, I'm belonging into this type. Most Russian people actually belong to this type, are not Arctic people. Arctic people live in the polar zones only. This is temperate zones, temperate ecotype. It's a mixture of Arctic and tropic. So they are both adapted for Arctic type of life in winter and tropic type of life in summer. This is most common type of people in Russia and Europe. So don't tell that your teachers belong to Arctic ecotype. What do you need to know about different ecotypes? When you live in your ecotype, yes, for example, I live in the temperate zone. If I want to go to the highland area, I will definitely experience some problem. I will have lack of oxygen, and I can die from lung edema. If I go from temperate to tropic area, yes, I will suffer from overheating, and I will suffer from unusual food. If I go to Arctic area, I will suffer from extreme temperatures, from fatty foods, and from lack of vitamins. I will suffer from lack of vitamin C in the food. Yes, I will have scurvy. So when you came from one ecotype zone to another, you need to know which problems you need to face. So during the winter, during the cold season, please put on proper clothes, and please watch your diet. Watch your diet. Make sure that you receive enough vitamins and minerals during winter season, and don't eat fast food or sweet food when you sit in your hostel rooms. It can result in bad consequences. You can listen to me, you cannot listen to me. It's your choice. My choice is to tell you this information. Adaptation types. Speed of adaptation. Another type of adaptation of people, how they respond to things which are going around them. Adaptation can be specific, non-specific. Specific adaptation is adaptation to specific response. For example, if I feel hungry, I want to eat. If I feel hot, I sweat. And non-specific adaptation is adaptation which provide response to any factor, like protein synthesis, yes, like glycolysis, etc. So according to adaptation types, there are people who adapt quickly, who respond quickly, people who adapt slowly, and intermediate very. So people according to adaptation types, according to speed of reaction, are divided into sprinters, according to sport terms, into stayers, and intermixed. Sprinter, stayer, and mixed. These are adaptation types of people. So sprinters are the people who adapt quickly, rapidly, who can bear quick amount of physical or mental loading, but to quickly get exhausted. So sprinters, in sports, these are guys which run very fast 100 meters, but after that they are completely tired. Stayers are vice versa. They can manage long-term but low intensity loading. Yes, they get adapted slowly, but they can work for a long time. They can tolerate the loading for a long time, like marathon people run 40 kilometers, but they run quite slowly. Yes, but 40 kilometers. And mixed is intermediate, so people who get adapted quite quickly, who worked quite a long time, and restore quite a long time. Why do you need to know who are you? Some of you are stayers, some of you are sprinters, some of you are mixed. For example, I have students who are sprinters. They came to foreign country, they know their few words, they know how to talk, to shop, to girls, to teachers. Yes, they come to morning class, they answer everything in morning class. At 7 p.m. they already become tired. These are sprinters. They get adapted very quickly. Some students are stayers. For example, I say, tell me the cell. Ma'am, tell me what is the cell organelles. Ma'am, okay, tell me what is the cell organelles. Cell organelles, and I think this guy is stupid. But during some point, suddenly this guy writes everything, and I know he didn't cheat. So these are stayers. These are stayers, and mixed are in between. Something in between. Why do you need to know who are you? Because if you are sprinter, you need to choose, for example, medical specialization according to sprint mode. For example, you are neurosurgeon. You woke up, you did operation in the morning, and then you are resting. You worked quickly, intensively, and then you are resting. Right, in medical case or something else. If you are stayer, you cannot respond very quickly. You cannot work maybe in the resuscitation ward. Give me this syringe, put this droplet, put this drug. If something will go on around you very fast, maybe you'll fail to adapt. You're not stupid, maybe you just need some time. But if you'll be therapist, cardiologist, yes, neurologist, when you will study a patient one by one, 200 patients a day, maybe it will be fine for you. And mix, you choose whatever you want. So please try to understand who are you. There are many tests. Maybe you'll do them in physiology. If not, you can read about this information and check who you are. If you will find job and activity to your adaptive type, your life will be easier and happier. So types of people adaptation, mechanisms of people adaptation are genetic adaptation. Yes, we are born with genes, certain genes. Yes, I told you about this many times. These genes give us specific, non-specific adaptation. Developmental adaptation, we can trail our skills. Yes, if you didn't learn properly in the beginning of class, if you train, repeat this information many times, for example, you can be ready. And physiological adaptation, short-term physiological changes which happen in our body run by nervous and endocrine system. So ecological systems. This question I included because it sometimes can be on exam and it's not written properly in your book. Ecological systems can be natural, lake, river, forest, grassland, yes, desert, natural ecosystems, and ecosystems which are artificial, which are made by man. Artificial ecosystems are classified into nature cyanosis, which look like natural but made by man. Nature cyanosis, for example, park. Yes, it is made by man but looks like real nature. Next, very popular is agricultural ecosystem. Agricultural ecosystem or agrocyanosis. We call it agrocyanosis sometimes. So agrocyanosis is field farm. You saw it's very common. Yes, most of wildlands are turned into fields and farms nowadays. By the way, these agricultural systems, they consist of mainly one species. Only cows, only sheep grow, only crops grow. Yes, only wheat grows. So one species or two species maximum. They have very high bioproductivity. Why we keep this agricultural system? Because productivity of one field can be several tons or even 1,000 tons of food for the city, for example. And they all the time need to be maintained and controlled by human. Because they consist of only one species, they are very unstable. They need all the time fertilization, because you take away all productivity, you need to bring new. And if you don't control it, if you don't watch them, they will be replaced by natural ecosystems very, very rapidly. If you don't apply pesticides, herbicides, pests and different herbs will destroy the field after 1 year. Urban ecosystem. Ecosystem of the city. It's very interesting ecosystem. Now all of you are in technosphere, yes, what we call technosphere, and in the urban ecosystem. So cities have its own atmosphere, hydrosphere, yes, flora, fauna, yes, specific. And most of cities have huge amount of artificial nature, have big amount of pollution. Pollution of cities not always belong to environment, water, soil. It's also dust pollution. It's also noise pollution. Yes, you always get tired from constant noise. It is light pollution. Day and night cycle are broken in the city. Heat pollution. Temperature in the city is hotter than in natural ecosystem. And modern cities take huge amount of resources. Yes, all the time take, and instead they produce lots of garbage, which also creates problem. So urban ecosystems are mainly artificial with big problems. And the most scariest of all ecosystems which are made by humans are called technical cynosis or technical ecosystems. These ecosystems don't have any living nature mostly. These are fully artificial factories, enterprises, or places of ecological catastrophes where environment become extreme. Environment can be favorable, unfavorable, and extreme or dangerous. Environment is extreme or dangerous for human long staying. Yes, these are usually places of ecological catastrophes where life cannot exist anymore. For example, Chernobyl station. You know that it is huge area of radiation pollution. But such places are not so rare, and all abandoned broken factories, chemical factories, hidden factories can be technocynosis, which are very, very dangerous. And finally, I have few minutes before you have your exams. Some of you, of course, will not have such stress, but some of you still will. And what is stress? Tropic stress is very interesting, is very important. You will study it next year also. And let's talk what is stress. So what is stress? Actually, Hans Selye, the author of this theory, said that stress is a response to any kind of factor which acts on the body of organism. Any kind of factor. But nowadays we say that stress has negative aspects. When we talk about medicine, we use stress in the more negative way. But initially, stress is a response to any factor which acts on the body. Stresses, factors which affect human bodies. It can be physical stress, like this sound. When I make sound, it affects your body. You say what's happening. You start to wake up if you're sleeping. Yes, it's a stress. Yes. So apart of physical, chemical stresses in human body, we also have catastrophic events. Yes, life changes, losing somebody's love, divorce, loss of job, and daily hustles, daily routine, running for job, running in traffic, burnout syndrome, which also my students made report in the conference. These all are results of daily hustles. You come from job, you didn't do much, but you feel tired. It can be due to routine stress. So due to different stimuli, we have different adaptation stages. Yes, we pass stress through adaptation stages, and stress can stop. Actually, stress actions can stop actually on any stress. This is how we get coping with psychological stress, appraisal, denying, reappraisal, etc. is for psychological stress, and these are general adaptation stages for stress. So first, when stress factor acts on you, you feel alarm stage. You check what is going on. Yes. So when they make sound, you start to move your hand. Yes. When door opens, you start to check what's going on. This is alarm stage. Your systems become misbalanced, and you are checking what's going on, what is happening, what should I do. Yes. If I stop making sound, your stress is gone. Yes. It doesn't need to go further stages. For example, students who have 4.7, they have chance for not passing exam. Yeah, for excellent path without passing exam. If you have to listen and then say, oh my god, oh, I have 4.7, I did conference, I have chance. Then another students, when you listen information you didn't find yourself in their lucky list, you start to go for resistance stage, you start to prepare for exam, you start to find answers to the questions we gave you, you start to remember something from biology, yes? And this is called resistance stage, when you try to figure out how to live with this situation, how to go back to your initial balance, when you try to manage things. So in this stage, animals do two things: either they run away, either they fight back. Yes, human cannot do this, so it has different mental things going inside of him or her. And if you didn't cope with the resistance stage, if you didn't manage to control the stress factor, eventually you go to the exhaustion stage. You run out of the resources and you go to exhaustion. You didn't study in class, you didn't study for exam, you have exam last night, after 1 hour test will start, you say, oh my god, okay, let it be, whatever it is, I don't care, I'm too tired for this. So this is exhaustion stage, when you cannot cope. If stress is intensive, it can lead to depression, it can lead to burnout, it can lead to disease. Sometimes the last stage also happens not because people don't do something and then they do everything, because they work too much, they don't rest. It also happens. So stress topic is extremely interesting. So these are stages by stress, yes. So activation, you stress, positive stress when you try to adapt, when you manage to adapt, and if you fail to adapt, you go to the stage called distress. So actually negative meaning of stress, which we use nowadays, I'm stressed, that means distress, I'm failing to adapt, I have too many things, I have too many things going around me, I'm too weak, I'm too tired. So this is called distress. Which adaptations, which specific adaptations we use in our body to run the stress reaction? So we involve hypothalamus, pituitary gland, adrenal glands. These are parts of endocrine system, and of course we use different zones of our cortex to cope with stress. Yes, so main hormones who run the stress in our body, who provide activation of body resources in our body, are hormones of adrenal glands. This is epinephrine and norepinephrine. So these hormones, epinephrine or adrenaline acts faster, norepinephrine acts slowly but lasts longer. So they increase blood pressure, increase sugar level, suppress immune system, yes, activate your attention, yes, decrease sensitivity to pain, and they are designed to adapt you for stress. If it is adrenaline, it is short-term reaction, quick response. For example, car is coming towards you and within a second you quickly jumped out. It was possible because of adrenaline. And norepinephrine make your body work in intensive regimen for quite a long period. It's a long-term stress adaptation. So positive effects or rather positive effects which you can feel when stress acts on you is heart increase, heart rate increase. Yes, if stress is tolerable when you manage the stress, after your heart increased, after a while it's continuous big heart beating, you feel emotional, but then eventually you come down. And the last phase, if you cannot manage stress, it turns into toxic phase. Nowadays you need to understand that people live in society has its own rules, When you have stress reaction, you cannot simply beat somebody, abuse somebody. Yes, you cannot do any action. That's why stress emotions, stress hormones circulate in your body for a long term. They you cannot use their according to their initial application. So many people in job are stressed. Yes, they want to show their emotion, but they cannot. And if they don't remove stress properly, it can cause different problems with health. So when you have stress, when you come to exam, when you try to write tests, of course you will be stressed, you will be activated, but this is okay. So please, after exam, when you pass the exam, when you get positive mark, you still feel that your heart is still beating. Yes, you still feel like you're activated, though situation finished. This is because of noradrenaline. If you don't want it to rise up your pressure and sugar level more than it you should do some physical activity. So getting rid of stress, which we all experience every day, is very important skill of modern human. So if you get stress, you need to do some physical activity. Then you need to eat something and you need to rest, you need to sleep. If you are too stressed and you want to take alcohol, that will not help. Organism will remain stressed, and after alcohol effect finishes, your stress will be continued. So when people want to relax, really relax. You do yoga, you do exercise, at least you watch movie, at least you sleep, but you don't use bad habits for it. Stress like this will not go, it will simply increase. And the next dose of alcohol or drug will be bigger because stress will accumulate. So please try to understand that stress is an important part of life. Unfortunately, it is an indispensable part of doctor's life. And your task and your skill is, I think it will be very useful if you know how to deal with stress properly. Because without stress, modern life of people is impossible. And of course, if you don't want to be very stressed in university, what you need to do? You need to rework in time, study in time, and attend classes. If you do like this, most of your problems will be gone. And the last thing, I have 3 minutes, is the biological rhythms. So our body, our nature, our planet is going according to certain frequency and is run by certain rhythms. Chronobiology is the science which studies biological rhythms. Biological rhythms is quantitative and qualitative changes, regular changes of body parameters. So when in your body something repeats with a certain time period, it is called biological rhythms. You open eyes, you close eyes. You breathe in, you breathe out. You fall asleep, you wake up. This is your heart goes intersystole, interdiastole. This is example of biological rhythm. Biological rhythm can be classified according to the time periodization. Intercircadian, circa means about, radian means day. A sleepwalk cycle, so it happens once in the 24 cycle for 24 hours. Body temperature, melatonin, hormone of your sleep, yes. Ultraradian, more than once a day. Appetite, hormone production. Infraradian, once a month, menstrual cycle, etc. And we have so-called, how these rhythms are regulated, we have so-called biological clock. Yes, we have in external daylight, yes, periodization which activates this clock, and we have internal clock which is run by our genes, yes, and these genes run production of hormones and the impulses which run over the body. So if our body rhythm start to be violated, if you don't sleep, for example, 1 day or 2 days, or you sleep only few hours, you start to feel broken, you start to feel body pain, you have bad mood, yes, you have bad feeling, you have weakness, you have tiredness, you have irritation, you have bad memory. This is example how a cycle gets broken, how chronopathology starts. Early aging, also breaking cycle, which is driven by constant stress, by bad ecology, etc., which I have told you before. If you have balance of hormones, thyroid gland, thyroxine, yes, if you have small amount of thyroxine, you become very slow, you have no appetite, no interest, you feel cold all the time. And vice versa, if you have too many thyroxine, you become like this, you become hyperactivated, your body runs much more faster than it should. For example, this clock goes with certain rhythm, but if it goes like this, very fast, it will break down, simply. Yes, it will stop working. That's what happens if our rhythms break down. According to rhythms, we prescribe certain drugs. We prescribe manipulations. When we have tooth extraction operation, we prescribe it for morning, because in the morning the sensitivity for pain is the lowest. Yes, we prescribe drugs according to time, especially hormonal drugs, so they match with our own hormonal level. Yes, and actually that's all information I want to tell you in our last lecture. I thank you very much for being with me this year. I'm very sorry that I couldn't see your beautiful faces. I really miss you. All teachers are missing you very much. For us, you all are very beautiful, and we are really hope that you are really heroes, will be heroes for your nation, that you will bring brighter future, that you will bring joy to your families. We really proud of your participation in conference, and we wish you good luck. If you travel home, I wish you goodbye, and I'm very hope that I will be able to see you next year. So please study biology, prepare for exam, and manage your stress. Goodbye and good luck.